Okay, Algebra 2. Today should be the 22nd, and we're starting Unit 5, Lessons 1, 2, and 3. What was Unit 5? It was sequences. So there's two basic types of sequences that we spend a lot of time on. Arithmetic, which is when we're adding, or it could be subtracting. So an example would be like, I don't know, 1, 4, 7, add 3, 10, 13, just keep adding 3. That's an arithmetic sequence. Difference would be 3. First term is 1. Geometric is when we're multiplying to get to the next term. So maybe you start with 3, then you double it, then you double it again, then you double it again, then you double it again. All right, there's a geometric sequence where I'm multiplying by 2. The ratio would be 2. First term would be 3. So if I say come up with the equation, you'd say, hey, 3, 2 to the n minus 1. That's the formula. First term, and then the ratio. All right, sequence, or problem 1. The sequence is defined by a recursive definition. Find the third term. They gave me the first term. So first I got to get the second term. Got to go in order. All right, so how am I going to get A2? Well, if I put 2 in there, 2 take away 1 gives me A1. There's the previous term. And then again, I put 2 in here, and I get 2 plus 1, which is 3. What was A1? 6. So I get 6 plus 6. So the second term is 12, which is not my answer, because I'm not looking for the second term, I'm looking for the third term. So what do I need? The previous term, A2. And then if I plug 3 in there, I get 3 plus 1, which was 4. So A2, we just figured out, was 12. And then 2 times 4 is 8. Add that up, I get 20. That's the one I want. Choice 3. All right, here's another sequence. 6, 12, 20, 30. It's not arithmetic, because I'm going up by 6, then I'm going up by 8, going up by 10. It's not geometric. But in this case, I'm just looking for the right formula. So let's say I think it's 3. Let's just try it. Don't forget, this tells you how to start. Remember? Start. And this is stop. Start, stop, and just count. So I'm starting with 2. If I plug 2 in there, 5 times 2, take away 4, that gives me 6. That's good. I want 6. But then I'm going to plug 3 in there. 5 times 3, take away 4. 15 take away 4 gives me 11. I'm looking for 12. That ain't the answer. All right, so process elimination. Keep checking them. I'm going to go down to number 4. If I plug 2 in there, I get 2 squared plus 2, and that turns into 6. 4 plus 2 is 6. If I plug 3 in there, 3 squared plus 3, that'd be 9 plus 3, which is 12. That's working so far. Plug 4 in there, I get 16 plus 4, which is 20. If I plug 5 in there, which is the last number, I get 30. So this is the one that works. The other two would not work. Okay, number 3. We got something being stacked here. So we got 2 in this first stack. We got 4 in this next stack. If you count those, you get 8. If you count all those up, you get 16. If I kept on going, I'd have 32. Then I'd have 64. ... What kind of sequence is this? Hopefully you say this is geometric. So I need my geometric formula, which is a sub n equals a1 r to the n minus 1. All right. Wants me to find the 20th. Do I know the first one? Yeah, first one was 2. What's the ratio? How am I moving? What am I multiplying by? 2. Be careful. 20 take away 1 gives me 19. All right, so I'm putting that in my calculator. So I got 2 parentheses 2 raised to the 19th power. A little over a million. 1,048,000 something. So between 1 and 2 million. All right, number 4. Recursive definition. Remember, this means previous. All right, so if the first term is -2, how would I get the second term? I take the previous term, -2, and add 5 to it. What do I get? 3. How do I get the third term? Take the previous term, add 5 to it. I get 8. How do I get the fourth term? Take the previous term, add 5 to it. I get 13. I think I see the pattern. So it was -2, then 3, then 8, then 13. Next one would be 18. Next one after that, 23, so on and so forth. This is an arithmetic sequence. So I'm going to pull out my arithmetic formula. Because it says find the 20th term. I don't want to write them all out. So how do I find the 20th term? I need the first term, -2. Again, 20 take away 1. There it is again, 19. And what's my difference? I keep adding 5. Put this in the calculator. Plus 19 times 5. I'm getting 93. So if I kept writing them all out, the 20th term would be 93, which is choice 1. All right, find the value. Remember, this means add. So plug 0 in. 4 times 0 plus 1 gives me 1. Then we're going to plug 1 in. Going to get 5. Then we're going to plug 2 in. We're going to get 9. Then we're going to plug 3 in. 12 plus 1 is 13. Then we're going to plug 4 in. That's the last number. We're going to get 17. What do we do with all these numbers? Sigma means add. Add them all up. So that's 39, 40, 45. You can use your calculator if you need to, but 45 is the total. All right, on to the back. Sequence is given by a recursive definition. Here's the first term. This means previous. What is the fourth term? I got to go in order. Got to get the second term. So I need the previous term, A1, which is 2. 3 raised to what power? Well, I'm looking for the second term, so I'm going to raise it to the second power. So this is 2 times 9, which is 18. What's the third term? I need the previous term, which is 18. And then it's going to be 3 raised to the third power this time. I need my calculator for this one. So what is 18 times 3 to the third power? 486. 486. Find the fourth term. One more. So the fourth term is going to be the previous term. 486. 3 raised to the fourth power is going to be large. So 486 parentheses 3 raised to the fourth. 39,366. Here's the fourth term. Obviously not geometric or arithmetic, crazy sequence. All right, this sequence, not so crazy. It goes from 6 to 13, add 7, right? Add 7 more, add 7 more. If you kept on adding 7 more, eventually you get to this. Okay. What's the common difference? That's easy. 7. How do I get from one term to the next term? I'm adding 7. What's the formula? All right, well, they gave me a formula for arithmetic sequences. Do we know the first term? Yep, 6. N is our variable instead of x. Do we know the common difference? Yeah, 7. There it is. You can leave it like this. If you want to distribute and simplify it, go ahead, but that's extra work that you don't need to do. How many terms are in the sequence? All right, so, I mean, I could write them all out, and that would take a while, but there's the last term. See, I'm going to plug that in there. I'm going to say, all right, the output is 244. What's the input? Solve for n. So I'm going to take away 6. That gives me 238 equals n minus 1 times 7. Hopefully when we divide by 7, I get a whole number. 238 divided by 7. 34 is equal to n minus 1. Add 1 to both sides. So there are 35 terms. How many terms are there? 35. All right. This is the same kind of question, only it's a geometric sequence. Tricky though, because how do you get from 81? We don't know the second term, don't know the third term, don't know the fourth term either. We got the fifth term. All right, so I got the first term, I got the fifth term. I'm multiplying. By what? What am I multiplying by? I don't even think it's a whole number. All right, so maybe that geometric formula could help me here. So I got the fifth term. I got the first term. I don't know what the ratio is. Don't forget, if the fifth term means 4. See, I went over 1, 2, 3, 4. I had to go 4 spaces over. So I want to solve this. Divide by 81. I'm just going to leave that there. And then I'm going to take the fourth root, both sides. Fourth root. So I want to take the fourth root of that. All right. How do I do that? Let's go into math. Now I got to hit the number 4. Then go to math. Okay. Option 5. The fourth root of 256 divided by 81 is 1.3 repeating. If you hit math and change it to a fraction, we're multiplying by 4/3. It's a lot of work to get that first answer to A. What's the ratio? 4/3. That's what we're multiplying by. You could fill in the blanks now if you wanted to. 81 times 4 divided by 3. So like the next term would be 108. This is 108. You could fill in all the rest if you wanted to. What's the formula? I almost got that done. Got the first term is 81. We just figured out the ratio is 4/3 to the n minus 1. Done. What would be the 10th term? 81. 4/3 raised to the 9th power, not 10th power. 81. 4 divided by 3 raised to the 9th power. I'm sure it's going to be a messy number. Maybe if I hit fraction. Nope, it's not going to do it. So I'm just going to write that down. 1078. I didn't say what to round to. We'll go 78. 781 dot 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 dot. Irrational. No, it's probably rational. But okay. The last one. We want to come up with all the outputs from 3 to 6 and add them up. Unfortunately, you got to do them all. Well, there's number 1. There's number 2. So what's the third term? It's 3 times the previous. 3 times the previous. Well, the previous term was 3. Minus twice. What does this mean? The one before it. The first term. It's tricky. You need the 2 previous terms. The 2 previous terms. So there's the previous and there's the one before it. So you end up with 9, take away 4, which is 5. There's the third term. Third term. Now I gotta get the fourth term. 3 times something, 2 times something. What's going to go here? The previous term. What's going to go here? The one before that, which was the second term, right? Yeah, second term. I have to think about this. So I get 15, take away 6, and that is 9. And I want the fifth term. We also want the sixth term. You should try this on your own. Pause the video and do it on your own, but I'm going to just keep going. 3 times the one before it, we just got that, 9, minus 2 times the one before that, which was 5. So I'm going to get 27, take away 10, which is 17. One more. The sixth term. 3 times the previous, that was 17. 2 times the one before that, which was 9. 3 times 17, 51, take away 18. 51, take away 18. Don't want to mess up here. 33. Now what? Take these 4 numbers, add them up. 33 plus 17 plus 9 plus 5. Gives me a total of 64. That's the final answer. Find this sum, 64. All right. Now, you got some independent work to do, similar. Make sure you show me work on the back. If you want to show me work on the front, that's even better, but make sure you show me the work on the back. All right, stay safe.